Students, you are welcome to this session. I am by name Kiden Robina, and I will be taking you through this module under anatomy and physiology. So today we are going to be looking at blood grouping. We have looked at a number of things from the introduction. We have looked at cells, tissues. We have looked at the body fluids. So today let us look at the blood grouping, then we shall also continue with the other units under this module. So um, before blood transfusion, it is necessary to determine blood groups of recipient and donor in order to avoid a mismatch. The person who is receiving blood should receive blood that really matches with his own that he has in the body so that we don't get reactions. So the process is what is called blood grouping or blood typing. We want to find out which type of blood exactly does this person have so that we can give to him after making sure that this type of blood is safe for him and we shall not get a reaction. The membrane of human red blood cells contains a variety of blood group antigens, and these antigens are what we call agglutinogens. So at least 30 commonly occurring antigens are present in the human body, but many more still exist. But the ones that are now well known to us are around 30. So most of them are weak, important in studying genetic inheritance. So they do not cause much harm. That's why they are termed as weak. Historical background of blood grouping. Where did we get this idea of blood grouping and why is it being practiced? So at the beginning of the 20th century, an Austrian scientist by the name of Karl Landsteiner noted agglutination in some patients. So when we talk about agglutination, it's like clamping together of some substances. That is what we mean by agglutination. So this scientist observed that there was some clamping of blood or agglutination of blood in some of the patients. So he made a note of the patterns of agglutination and showed that blood could be divided into groups. Something came into his mind and said that if there is this kind of clamping together, then likely there is something behind this. Likely the blood is divided into groups. So this marked the discovery of the first blood group system, what we know as ABO, and is the most used currently. It guides us in doing our clinical work. So in 1910, scientists proved that the red blood cells antigens were inherited and that the A and B antigens were inherited codominantly over O. So that means that if one parent is having blood group O and the other parent is having blood group A, the offspring is most likely to take blood group A than blood group O. That is why we say that it is inherited codominantly. So in 1924, Bernstein also developed what is known as the three allele model. So let us look at the ABO blood grouping. When type A agglutinogen is present, that is blood group A. When type B agglutinogen is present, that is blood group B. When type A and B agglutinogens are present, it is blood group AB. When neither type A nor type B agglutinogens are present, then it is blood group ABO. So that is self-explanatory. I don't need to go into details. So ABO, blood grouping, we are still continuing. So the prevalence of these different types of blood groups is as follows. The highest percentage of human beings have blood group O, and this makes up to 47%. Then in blood group A makes up to 41%, and the blood group B makes up to 9%. Then the least is the blood group AB, which makes up to only 3% of the individuals. So two systems are involved in the blood grouping, and in this we have the ABO system, which I have already talked about, which is talking about the antigens that are found on the surface of the red blood cells. Then we have the rhesus system. So let us start by looking at the ABO system. So two antigens or agglutinogens occur on the surface of red blood cells. That is, we have the type A antigen and the type B antigen. So let us look at the origin of agglutinins in the plasma. Where do they come from? So antigens similar to A and B are common in intestinal bacteria in foods to which newborn individuals are exposed. So these antigens are common in the daily food that people eat. So as the baby is born, he is exposed to these antigens. He takes them every day, and the results he will end up the body will get used to one of the antigen and will not get used to another, maybe if he's not exposed to that specific one. So if that specific one now comes into his body, is looked at as a foreign body. If you can remember when we talked about phagocytosis and how the body is being defended, then you will remember, you will get to understand very well that the body will react in case the antigen enters for the first time. So infants develop the antibodies against antigens that are not present in their own cells. Thus, type A individual develops anti-B antibodies, and the type B individual develops anti-A antibodies. So if the person um, is having type A, it means that he's exposed to the antigen or agglutinogen A. Then that means that if he's exposed to antigen B, he will react. So someone who is having blood type A will have antibodies against the blood type B. So he will react to it, and vice versa. So a type O individual develops both anti-A and anti-B antibodies. So he will react to both blood from someone who is having type A and type B. He will react to it because he has those antibodies against the two antigens. So while a type AB individual does not develop any antibodies. So the type AB, the one who is having AB as the blood group type, he does not have any or does not develop any of the antibodies. So he is termed as a universal recipient. He can receive blood from any of the people because he does not react to any of them. So let us look at titer of the agglutinins at different ages. So right there in that figure, we have at age 2 to 8 months, this is the first appearance of the antigens in the body. Then from 8 to 10 years is now the maximum titer. So above 10 years, now it starts declining. So when you see right there, we have the blue line stands for anti-B agglutinins in groups A and D or blood. Then we have the red one, anti-A agglutinins in groups B and D or blood. So you can see that at first both of them rise up until when the person makes 10 years, then they start dropping slowly. So let's look at agglutination. Agglutination occurs because agglutinins can have more than two binding sites. So as you can see in that pictorial right there, you can see that these substances, or what we call the agglutinins, are binding to more than two binding sites. So because of that, they cause what is called the clamping. Then these cells will clamp together, then hence agglutination. So a single agglutinin can therefore attach to more than two different red blood cells, causing the cells to adhere to each other, forming clamps. So clamps are later attacked by phagocytosis, then they are destroyed, and as a result the red blood cells are also destroyed alone. So that is the worst part of it. Remember when we talked about phagocytosis as one of the non specific defense mechanism. Once they identify um, something that is abnormal, the white blood cells immediately will come and cycle that particle or that substance that looks abnormal to them, then they end up killing it. So this is what will happen in case these red blood cells clamp together or agglutinate. So we are still continuing with agglutination. Transfusion agglutination is referred to as transfusion reaction. So acute hemolysis when donor and recipient blood are mismatched. So this normally leads to that. So this occurs immediately after the transfusion in some cases. This is due to the activation of complement system. So the complement system is where the antibodies and the antigens, they are clamped together or they agglutinate, and as a result there are proteolytic enzymes that are released. So the proteolytic enzymes will come and attack this particle that has been formed because of the agglutination, and they end up rupturing the red blood cells in them. So when plasma of type A individual is mixed with the type B cells, the anti-B antibodies cause type B red blood cells to clamp together, what we term as agglutination. This is what I had just described before. So sometimes they can react immediately, or sometimes can lead to what is called the delayed hemolysis. This is also common. This is where the red blood cells will be destroyed days or weeks after the transfusion has been done. So the person does not develop those reactions immediately. Let's look at incompatibility in ABO system. So right here we have the table which shows the blood phenotype, agglutinogens and the agglutinins. So the blood group type, we have O, A and B. So then we have the agglutinogens on red blood cells, agglutinins in plasma, agglutinates red blood cells of type. So if someone is having blood type O, the person will not have any of the agglutinogens, does not have any of the antigens, either B or either A or B. So he does not have any of the antigens. Then he will have agglutinins in plasma, that is anti-A and anti-B. That is why someone with blood group O will only receive blood from someone with blood group O. Why? Because he has the anti-A and anti-B, and once transfused with any of that blood type, he will end up getting a challenge or getting a reaction. So the person with blood group O will have the following agglutinates. Will agglutinate with someone with blood group A, with blood group B, and blood group AB. This means that if he's given blood from any of these, he will react to it. That is why I said that he will only receive blood from someone who is also blood group O. Then someone with the blood group A will have antigens A on the surface of the red blood cells, and they will have agglutinins in the plasma, which is known as anti-B. So it means if this person is given blood from someone with the blood group B, he will react to it. So right here we can see that someone with blood group B and someone with blood group AB will not be able to donate to this person because the person will react to it. Then blood group B, right there, we have the person will have antigens B or agglutinogens B on the red blood cells, and will have anti-B. So this person, if he's given blood from group or someone with blood group A, and he has another one with blood group AB, will also react to it. Why? Because he has the anti-A. So we'll only receive from B and O. Then this one of A will also receive from O and A. So then the next one right here, we have blood group type AB. The blood group type AB has the agglutinogens A and B, and for them they do not have any anti, and for that reason, therefore, they cannot agglutinate with any of the blood. So they are universal recipients. They can receive from any. Though we are talking about universal recipients and universal donor, we have to put in mind also the issue of rhesus factor, as we shall look at it as we continue. So individuals with let us look at incompatibility in ABO system. We continue with it. So individuals with the type AB blood are termed as universal recipients. They can receive blood from any person with any type of the blood. That is, can be O, A, B, or AB, and they have no circulating agglutinins, can be given blood of any type without developing a reaction due to ABO incompatibility. Individuals with the type O blood consider rhesus factor, rhesus negative or universal. Rhesus negative are termed as universal donors. So this is what I had talked about before, that though we said that the group O individuals are universal donors, we have to consider the rhesus. When they have rhesus factor negative, so it means that they do not have the rhesus D, and they will be able to donate to anyone. So whoever is group O rhesus negative will be considered a universal donor. We also have to consider that the ABO, meaning the AB, lack I mean the O lack A and B antigens. I beg your pardon. Lack A and B antigens or agglutinogens, so they don't have this on their surfaces. Why? Because they don't, so that means that they can not react to any of these. Then type O blood can be given to anyone without developing reaction due to ABO incompatibility. But remember, resource factor, that one we have talked about it. Blood grouping, we continue. So results of blood grouping experiment. Right there we have a pictorial which is showing us the red blood cell type O, A, B and AB. Then we have the serum with anti-A. The one of O is negative, the one of A is positive, the one of B is negative, then the one of AB is positive. Then serum with anti-B, the one of O is negative, the one of B is negative, the one of A is negative, the one of B is positive, and the one of AB is positive. So red blood cells are diluted with the saline. One portion is then mixed with the anti-A agglutinins. Another portion is mixed with the anti-B agglutinins. Type B cells have B agglutinogens. They agglutinate blood with anti-B. Then type AB cells have both A and B agglutinogens. Production of antibodies is stimulated when the immune system encounters the missing ABO blood group antigens in foods or in microorganisms early in life. So early, like I mentioned before, that when the person is not exposed to such antigens, with the time the body starts reacting to them. So let us look at the blood genotypes. We have right there in that pictorial, you can see that we have BB and BB. So these will give offsprings that have BB throughout. Then we have BO and BB. Here we shall have BB, BO, BB, and BO. And this side we have BO, BO. So this will give us BB, BO, BB, and OO. So A and B antigens are inherited as the Mendelian allelomorphs. So A and B are dominant. So that is why you see that if the parents were having maybe one parent was having blood group O and the other one was having blood group B. If they produce their child, the child will have the BO, but the child will have blood type B. Why? Is because the A and B antigens are dominant. So we continue with that. So here is clearly stated. So here we have the father's alleles, then we have the mother's alleles. So you can see that on the ABO of the father, if the father is having blood group A and the mother is having blood group A, they will give birth to an offspring with A. If the mother has B and the father has Z, A, they will give birth to an offspring of AB because both A and B are strong. Then if the mother is having O and the father has A, the offspring will have A. And it will continues like that. So you will see that the only situation in which the offspring will have blood group O is when both parents have blood groups O. Then right there, we have the blood group, then the antigen present on the red blood cells, then the antibodies present in the serum, and the genotype. So if the person has blood group A, the person will have antigen A, then the person will be anti-B, and the genotype is AA or AO. So this about the antigen and the antibodies, we have already mentioned them before. I'm not going to go into details of that, but let us pay attention to the genotypes. Here, this means that this person who is being portrayed as having blood group A has in his blood either AA or AO. This means that the parents were either having blood group AA, the mother A, the father B, or the one of the parent was having blood group A and the other one was having blood group O. That is why you end up with the A. Then also here, the same. Then with the AB, for you to have any offspring of AB, the parents might be having AB, or the person in his blood is having AB. So when you test, you will get that he's having AB. Then the person who is having blood group O means that he has in his blood a combination of O and O is what will give him blood group O. Then the genotypes right there, we have the OO, the OA, the AA, OB, BB, then AB. Then the blood types will be O, B, B, AB. So that means if the person has these genotypes, if you cross using the Mendelian system, you cross, you get this. If the person has OO genotype, is going to have blood group O. If he has OA or AA, remember that these are dominant. The A and B are dominant. So where there's OA or B, automatically the A will either be taken or the B will be taken. So where there's AB, the person ends up with AB. So the person of O does not have any agglutinogen, and the agglutinins he has the anti-B and the anti-A. This we have talked about them several times now. So let us look at other agglutinogens. In addition to the ABO system of antigens or agglutinogens, there are other systems like the rhesus, the Lutheran, KEL, KID, and many more. So amongst these, the most important we are considering are the ABO and the rhesus system. So let us look at the rhesus system. We have already looked at the ABO. So the rhesus system is of great clinical importance. The rhesus factor is named after rhesus monkey because it was studied using this animal. So rhesus blood type. Rhesus system is composed of C, D, E rhesus factors. Individuals have one of each of the three types of the rhesus antigens, but the one that is of the most clinical importance is the rhesus D. So the term rhesus positive means that the person has rhesus D, and the one that do not have rhesus D is termed as rhesus negative. So the others, if the person is not having rhesus D, it means that he may be having either rhesus C or rhesus E, but is not of so much clinical importance because they do not have much effect on the bodies or on procedures that are being carried out. So that is why more emphasis is put on the rhesus D. So in prevalence of antigen D, we have the whites have 85% uh, rhesus D, and the ones who do not have rhesus D are only 14%. Then the American blacks or black Americans, 95% have rhesus D and the 5% do not. Then African blacks, 98% have rhesus D. So like I told you, this can be determined by the nature of your inheritance. If your parents had, you are likely to have the same. And also the kind of foods and the environment that you are exposed to. So characteristics of rhesus transfusion reactions. So first exposure of negative person to rhesus positive blood, delayed and mild reaction within 2 to 4 weeks can happen. Then the second exposure in most cases is severe and immediate. So when the person is exposed for the first time, the reaction is delayed, does not react immediately. But for the second time, the person now reacts immediately, and in most cases it is severe. So let's look at formation of anti-rhesus agglutinins. Unlike the antibodies of the ABO system, the anti-D antibodies do not develop without exposure to a rhesus antigen. So unless you are exposed to that rhesus antigen, you cannot develop any of these agglutinins. So blood transfusion, that is 2 to 4 months later, maximum concentration. Entrance of fetal blood into maternal blood. A rhesus negative individual who had received the blood transfusion of rhesus positive blood develops anti-D antibodies. So these are the situations through which you can be able to develop the anti-D antibodies, mainly through transfusion. Then secondly, like for instance, if the mother is rhesus negative and the husband is rhesus positive, if she is carrying the baby for the first time and during birth the blood of the baby mixes with the one of the mother, likely the mother will develop the antibodies against these uh, rhesus. So may develop transfusion reaction when transfused with D positive blood even after several years. So the reason why it happens that way is because the baby will normally take the rhesus of the father. So is likely to be rhesus positive, or is likely to take the rhesus D. So, and the mother is remaining with her rhesus, which is not rhesus D. And that is where the problem comes in from. So let us look at erythroblastosis fetalis. So this is the condition that I have been trying to describe. Let us look into details of it. This is a hemolytic disease of newborn, and it affects a child of rhesus negative mother and a rhesus positive father. The fetus will have rhesus positive antigens on red blood cells. Small amount of fetal blood leak into maternal circulation at the time of delivery. The mother develops some anti-rhesus positive antibodies. During the next pregnancy, anti-D agglutinins pass into the fetal circulation, causing hemolysis of fetal red blood cells, hence hemolytic anemia. So what happens is the first time the child is born, the first time the mother becomes pregnant, she is negative, rhesus negative, is not having the rhesus D. Then the father is having the rhesus D and is termed as rhesus positive. When the mother conceives for the first time, when she is giving birth, there are chances that the blood from the mother, from the baby, because of the maneuvers through the vagina for the baby to be delivered, the baby may end up being bruised, and the mother has those tears, so the blood may end up mixing. So the body of the mother now makes antibodies against the rhesus positive. So the next time this mother conceives, it finds when the uh, antibodies against the rhesus D present in the body. So when another child is conceived, of course, the child will still take the rhesus D of the father, and in this case, the body of the mother will look at this baby as a foreign body, and will now start by destroying the red blood cells in the baby, leading to anemia, and the baby can end up dying. So the incidence of erythroblastosis fetalis happens as follows. The first child, normally there is no harm. The second child, normally there is 3% show of signs. Then the third child, 10% of the babies show signs, and it raises progressively. So every time the mother becomes pregnant, the chances of the pregnancy surviving reduce. Why? Because the body of the mother is becoming more sensitive to this baby that, or this fetus that is being termed as a foreign body right now. So effect of the mother's antibodies on the surface, I mean on the fetus. Antibodies diffuse slowly across the placental membrane and then cause agglutination of the fetus blood, hemolysis, and end up releasing hemoglobin into the blood. So fetus macrophages convert hemoglobin to bilirubin, and because of that the fetus ends up becoming jaundiced. Other body cells too may be attacked and damaged, and in most cases, the fetus can end up dying in the womb. So let us look at the clinical picture of erythroblast. So, in this case, the child is likely to be born jaundiced and anemic. The rhesus antibodies persist in blood for 1 to 2 months, destroying more red blood cells. Increase the rate of erythropoiesis, and in this case, many nucleated blasts, hence the name the erythroblast disease. So when we talk about erythropoiesis, we are referring to the process by which the red blood cells are being formed. So this condition can lead to death. If the baby does not die, the survivors normally have permanent mental impairment or brain damage. Kernicterus can also develop, and this is um, precipitation of bilirubin in neuronal cells. So the treatment that can be given, the baby's blood can be replaced with rhesus negative blood, normally 400 milliliters for 1.5 hours or more, within 1.5 hours or more, as soon as the baby has been born. Then anti-D antibody can be administered to negative mothers 28 to 30 weeks of gestation. This can help to save the baby's life. ABO antibodies are of major clinical significance because they are naturally occurring and they are found universally, and they are highly reactive. So that is why in most cases when uh, caring for patients, we consider the ABO system of blood grouping because it's the one that is universally known to everyone. And this can help to prevent adverse transfusion reactions, and errors may lead to death. So this should be taken seriously. Tissue transplantation. The ABO blood group antigens occur on a number of human tissues. So these are present also on T cells, B cells, and the platelets, and they can cause graft rejection. So if someone has a different blood type and he is given an organ of someone with also a different blood type, the organ may end up being rejected during tissue transplants. Like for instance, someone is given a liver from a person who has a different blood type can cause that rejection, or a kidney and many others. So thank you so much for listening to this. I wish you well. God bless you.